Now lesson 3.3, it's polynomial equation and inequalities. Let's just take a small reminder. What does mean polynomial, linear, quadratic, and cubic? Polynomial, it has the form of axn plus bxn minus 1 plus till c. And we need to be careful that the exponent cannot be negative. Linear, so it's an equation of a line equal mx plus b. Quadratic, so it's ax squared plus bx plus c. It's a U shape, and the cubic is a cubic degree, and it has a snake shape or this shape. What we're gonna learn here, how to use long division, synthetic division, and the remainder theorem. This is all what about this lesson. We start with the long division, how we will divide it and how we're gonna write the answer. So if I want to divide 3x4 plus 4x3 plus 2x squared plus 3x minus 1, I want to divide it by x squared plus x minus 2. I will change the color to be able to do it properly. Then I'm going to think about what times x squared gives me 3x4. Or you can, on the scratch, write 3x4 over x squared gives me which answers? 3x squared, so I need to multiply by 3x squared. If you cannot do it mentally, you can do it on the scratch. Then I will start to multiply. 3x squared times x squared, 3x4. 3x squared times x gives me plus 3x3. 3x squared times minus 2 minus 6x squared. And then I need to subtract, or we can say I will change the sign. So here it's plus, it's minus, minus, plus. So I'm subtracting. 3x squared minus 3x squared, 0. 4x3 minus 3x3, it's x3. 2x2 plus 6x squared, so it's plus 8x squared. And then I will take down the plus 3x minus 1. And then again, what times x squared gives me x3? It's times x, so I have plus x. So x times x squared is x3. X times x, so plus x squared minus 2x. And then again, I need to subtract. So minus, minus, plus. X squared minus x3 minus x3 is 0. So here it's 7x squared. I have here plus 5x minus 1. Can I continue the multiplication, the division? Yes. What times x squared gives me 7x squared? It's plus 7. So I will multiply by 7. It will be 7x squared plus 7x minus 14. And then again, I need to subtract. Change the sign, so it's minus, minus, plus. So 7x squared minus 7x squared, 0, 5 minus 7 minus 2x, and here 1 minus 1 plus 14, it's plus 13. And this is the remainder of the division. Okay, we did that, but now how are we going to write the answer? How we will write the answer? The answer of the division, it's equal 3x squared plus x plus 6. And I still have the remainder minus 2x plus 13. So how are we going to write it? So I just want to duplicate to be able to see it. Okay. So the answer is, I have it here. I just need to keep it to see it. So the answer, so it's equal 3x. How do we write it? Let me write it this way. So when I do the division, so it's equal to 3x squared plus x plus 7. And I still have plus the remainder minus 2x plus 13 over x squared plus x minus 2. Why, miss, I write it like this? Because, guys, if I am saying that, so if I'm saying that, so this expression here, the numerator, I can replace it by what? I can replace it by 3x squared plus x plus 7 times x squared plus x minus 2 plus the remainder. So I will write it this way to see how I can, why I can write it like this. So when I do like this, it means I can say 3x squared plus 4x3 plus 2x squared plus 3x minus 1 over x squared plus x minus 2. It's equal to what? It's still here over x squared plus x minus 2. Okay, what the numerator is, how can I write it also? It's this times this plus the remainder, isn't it? So the numerator is 3x squared plus x plus 7 times x squared plus x minus 2 times x squared plus x minus 2. And then I still have plus the remainder minus 2x plus 13. No, I'm sorry for the 100. So if I separate those fractions, I can separate it. I can write it like this. I can write it like this: 3x squared plus x plus 7 times x squared plus x minus 2 over x squared plus x minus 2 plus minus 2x plus 13 over x squared plus x minus 2. This one we can simplify. So how I can write it: 3x squared plus x plus 7 plus the remainder over the divider. So this is the way how to do the long division and how do we write it after the long division. Now I'm going to move to the syntactic division. The syntactic division, I cannot use it if the degree of divisor is not 1. If it's bigger than 1, I need to use all the time the long division. So the syntactic division, when I'm dividing by a polynomial with degree 1, so I can do it. How are we going to do syntactic division? So we're going to make a table here, and then we're going to put the coefficient of the polynomial here in order. X3, x squared, x gonna need to be careful. If it was, for example, 3x3 minus 7x minus 19, we need to be careful to put the coefficient of x squared is 0. So in order, the coefficient of x3 is 3. Then x squared, 11. X is minus 7. And the constant is minus 19. I'm dividing by x plus 2. So what is the root? It's x plus 2 equal to 0. So x is equal minus 2. So I'll put the minus 2 here. And then I will take the first coefficient as it is 3, and then I will multiply it by the root here. 3 times minus 2 minus 6, and then we add 11 minus 6 is 5. Then 5 times minus 2, it's minus 10. Then we add minus 10 plus minus 7, so it's minus 17. We multiply, it's 34, and then we subtract. So, and we subtract that minus 19 plus 34. The answer is minus, it's 15, sorry guys. And then this is the remainder of the division. It means, what is the answer of this division here? The answer is, this is the coefficient of x squared. So the answer of the division is what? So it is 3x squared plus 5x minus 17. And what is the remainder? 15. So how are we going to write the answer of the division? So if I want to write it, let me duplicate to see them, yeah, like this. Because I want to see the given. I will keep like this. So if I want to write it as a fraction, okay, like this. So if I want to say 3x3 plus 11x squared minus 7x minus 19 over x plus 2, what is my answer? It's 3x3 plus 5x minus 17 plus my remainder. What is the remainder? 15. Let's keep it like this. Yeah, plus 15 over x plus 2. So it's exactly the same as I did in the long division. How do we write it? So like this. Let me erase all this. And this is my answer. I write it like this. So the syntactic division, I can just choose it when I'm dividing by the divisor of degree 1. The long division, we can use it all the time. And when I say that when the remainder in the syntactic division is not equal to 0, it means it's not, x plus 2 is not a factor. So it means I cannot use it to factorize the expression. I will explain for you what I'm saying. Okay, that's it. No, the remainder theorem. What does mean the remainder theorem? We can use this theorem to know the remainder of the division by a divisor of degree 1 without doing the division, without dividing. So I can, without dividing, know what is the remainder of the division by a divisor of degree 1 when I'm dividing this by this polynomial. So what is the remainder when, for example, x3 plus 2x1 is divided by x minus 1? So it's very easy. All what we need to do is to replace x by 1, because here the root is, the answer is 1. When I solve it equal to 0, it gives me x is equal to 1. So I replace x by 1. 1 plus 2 minus 1, so it's equal 3 minus 1, so it's equal to 2. What does it mean? It means when you divide x3 plus 2x minus 1 by x minus 1, the answer is 2. This method will help me to see if x minus 1 is a factor or not, to be able to factorize. So, for example, if I want to, the remainder theorem also helps to know if the divisor is a factor. For example, x3 plus 2x minus 3. If I want to divide by x minus 1, if I want to see if it's a factor. So first of all, I will replace x by 1. So I will have 1 plus 2, 3 minus 3, 0. So I can say that x minus 1 is a factor. What does it mean? It means I can write x3 plus 2x minus 3 as x minus 1 times a polynomial. This polynomial should be degree 2 because already this is degree 1 times degree 2 gives me degree 3. So now to be able to find what is this factor here, I use or either the long or the syntactic division. But I will use the syntactic division because I'm dividing it by x minus 1. So I will put the coefficient of those. Did you see, guys, here? So this is x3, x squared, x constant. Since there is no x squared here, I will replace its coefficient by 0. I have 1, 0, 2 minus 3. The root is 1 here. I take 1 down. 1 times 1, 1, 0 plus 1, 1. 1 times 1, 1. 2 plus 1, 3. 3 times 1, 3 minus 3 plus 3, 0. Did you see that also? I'm double checking as I did well, so the remainder is 0. So what is the answer? It's x squared plus x plus 3. So it means that now, how can I factorize x3 plus 2x minus 3? It's x minus 1 times x squared plus x plus 3. If I want to factorize more, I need to do delta here for this quadratic equation. Here delta is negative, it means I cannot factorize. So it means that this is the final answer for the factorization of this polynomial. So every time I want to fact check if it's a root, I can use the remainder theorem. No need to divide, to do all the division. All what we need to do is to use the remainder theorem, and this one will help me to see if this factor, x minus 1, or this expression, sorry, it's a factor of any polynomial. That's it for this lesson. It's very easy, and also, as I said all the time, I say we're going to do more application in the class.